Okay, today we're learning more about our egotistical friend, the parabola. So for the past 2 days, you've studied how to find the roots of the parabola. That's where it crosses the x-axis. So this whole parabola is so important that it had a whole chapter assigned to it. So when I say parabola, it's also known as the quadratic. It's also known as a polynomial of degree 2 because it is a x squared plus bx plus c. Its highest degree is 2, so that makes it a polynomial of degree 2. And this is what its mugshot looks like. So we're going to study all about this little curve in this chapter, and we're up to the second part, the discriminant. A parabola wants us to know all about its roots, where it crosses the x-axis. That is huge. It's huge in calculus. It's huge in operations research, which is the study of business flow. So we're just starting with the baby stuff today. All right, so let's look at the 4 things that can happen with a parabola. Here we are with picture 1. All right, picture 1. Imaginary roots. It doesn't cross the x-axis. Now you haven't learned imaginaries, that's tomorrow's lesson, but it can't have any roots if it doesn't cross the x-axis because roots are where it crosses the x-axis. That one makes complete sense. All right, we have the second case over here. All right, so that didn't make my little spotlight. Let's try that again. There it goes, it disappears. We have one real root, and it happens to be rational. There we go. And that's when the parabola only crosses the x-axis once. That's why it says one real root. It's the last 2 down here that if you take a quick look at their mugshots, it's crossing the x-axis twice. But it's how they cross the x-axis. So this one right here, it's crossing twice. But the roots are real, rational. This one, again, looks just like the other one. It has 2 roots, but they're irrational. So let's look at those closely. Sometimes they'll ask you to just describe the roots of a parabola. They don't want you to actually find them. It's like you describing a person. Oh, you know, the person has blonde hair, blue eyes, it's a girl, she's like 5'2". I described the girl, but I didn't actually name the girl. Who was I talking about? Casey. All right, so let's look at some of these. Here's my first equation I want to look at. All right, if I look at that, I can graph that on a graphing calculator. Here it is graphed. Let's put this on projector mode so you can see it a little better. And it crosses at 0.3333, which is 1/3, and -2, 0. So tell me about those roots. Well, it's not imaginary because they do cross. It's not one root because there are 2 roots. So this example is an example of 2 rational roots because the number 2, negative, and 1/3 are rational numbers. So if I were to describe this, it would be 2 rational roots. Now, if you didn't have a graphing calculator to do that, that's where the discriminant comes in. Notice I have the quadratic formula up here, but we're going to take the discriminant. And the discriminant is that little b squared minus 4ac. So if I just took from here, if I took b, which is 5, 4a, which is 3, and c, which is -2, and I figured that out, that gets me 25 plus 24, I get 49. And guess what? I can take the square root of 49. That's what makes it rational. I can take the square root of 49. All right, let's look at our next example. X squared plus 5x minus 2. All right, describe the roots. Are there 2 roots? Is there 1 root? Are there no roots? Well, let's look at the calculator. That's a big help. Okay, there's my, let me make sure I got that right. Nope, that changed that. Hold on. Okay, there we go. Now I have it right. Look at that root. It's pretty ugly. Let's look at this root. That's just as ugly. So I guess we can describe these roots. Well, there are 2. They weren't pretty numbers, so they're irrational roots. Let's do our discriminant again. So let's take b squared minus 4 times a times c. That gets me 25 plus 8, which gets me 33. Can I take the square root of 33? No. That's why your answers are irrational. All right, let's look at that one. Again, use your calculator. Let's the calculator give us a good hint about it. All right. Well, that one's pretty easy. Oh, geez. It crosses once, so when I go to describe it, I can say there's 1 root. And notice I left a blank here. Is it irrational or rational? Well, for the most part, you're in Algebra 1, and when there's Algebra 2, and they're not going to make anything hard on you, so it's going to be 1 rational root. And I can prove it to you using the quadratics discriminant. So I take b squared minus 4 times a times c. That gets me 64 minus 64. That gets me 0. Can I take the square root of 0? Yeah, I get 0. Now, some of you may be saying, well, wait a second, 0 is a perfect square, so why aren't there 2 rational roots? Well, that comes back up here to your quadratic formula, and we talked about that in the last video. If you did negative b plus or minus the square root of 0, you would get negative b plus 0 over 2a and negative b minus 0 over 2a, which both give you the same answer as negative b over 2a, both of them. So that's why there's only 1 root. Okay, let's get that out of there. And obviously, you know what the next root is, because if we go back to this page, we We did the two rational roots. We did the two irrational roots. We just did the one root, so this one's got to be an imaginary. So when we go to graph it, we should see that it does not cross the x-axis. All right, so let's turn that page. Let's bring on out the last graph. And let's look at it on our graphing calculator. And there it is. Even though it's upside down, it's still a parabola. And as we can see, it doesn't cross the x-axis at all. So that's why this one has no real roots. They're imaginary. So I would describe the roots as imaginary. They don't exist. And again, if I wanted to use my quadratic formula to prove that, kind of bring that over here, running out of room. I would get b squared. Here's my b. So that's 9 minus 4. A is -1. C is -5. And notice I get 9 minus 20. 5 times 4 is 20, and 3 negatives make a negative. And that gets me -11. And remember, that's under a square root. I can't take the square root of a negative number. It gets you imaginary answers, and therefore that's why there are no real roots. Okay, this is a chart, which at this point the video is over, and you're going to want to stop this video right here, pause this, and this chart is what you want to know. This is what I'm going to be testing you on. I want you to know if the discriminant is less than 0, this is what your picture is going to look like. Right? If the discriminant equals 0, we're only going to have one root. If the discriminant is a perfect square, we're going to have two pretty roots, two rational roots. If the discriminant is not a perfect square, we're still going to have two roots. They're just going to cross at ugly, irrational places. And if you notice in the background, I didn't choose this background just because it looked cool. If you looked at it closely, it's parabolas. See? It's parabolas. Oops. Let's move that up. It's parabola upon parabola upon parabola. And that's how they create a vortex. Okay, bring that back up. Pause the video. Copy it down. Quiz on it tomorrow if you're watching and listening. If not, keep failing.